The basics of it is that it's a parallelized runner for MuleSoft. It's a scope you can drop into a flow that allows you to run a series of processes in parallel. And the basic structure of it is this scope that's going to contain, is this batch scope that's going to contain a number of batch steps. And each of these batch steps can have multiple processors that they run through, and then finally an on-complete phase. In these batch steps, you can further break it down into the normal processors and an aggregator that allows you to be a bit more specific, or allows you to accumulate records and do something with groups of records. And you can have one of those aggregators at the end of each of these batch steps. Important thing to recognize about the batch scope is that it's a sort of asynchronous one-way operation where you're coming in from your event source and you're spinning off threads to run through this sort of heavy operation that you're setting up. So if you're importing 1 million records from a database and you're loading them into Salesforce, that'd be a good use case for the batch scope. It's going to come in, it's going to process those in parallel instead of processing them sequentially, which you would have to do without this batch scope. And then it's going to load them into Salesforce. And it can do that all asynchronously. What it doesn't do is sort of return back to the source. So if you're using an HTTP listener in your flow, you're not going to be able to use the result of the batch job in that HTTP response. So the batch job is sort of optimized for sources that are one way, not sources that are request response. If you have a request response, you need to hand back a response sort of without knowing the results of the batch job. So for example, if you had a HTTP listener at the start of this flow, you'd hand back an HTTP 202 response, an accepted, basically that, yes, we got your request, we're processing it, but you're not waiting until the end of the processing in order to return a value. And that helps keep this batch scope in the same spirit of the rest of MuleSoft, where you have sort of light, quick, fast processes. So you don't have some request that's just spinning for minutes while you're waiting for all these millions of operations to finish. So that's the basic setup of a batch job. The way it works is a bit more complex. So one of the main advantages of the batch job is how it allows you to take advantage of this parallelization without having to do all the setup yourself, without having to understand parallel programming at a deep level, without having to account for all the race conditions and all the tricky things that come as a part of trying to do things in parallel. It abstracts a lot of that away. But I think explaining some of what it is actually doing behind the scenes is pretty useful. So a batch job consists of 3 main phases. The first of which being this load and dispatch phase that happens entirely behind the scenes. This isn't really something you have a lot of influence over. Basically, you're going to take in your payload, whatever it is, your array of 1 million contacts, for example. It's going to take that payload, split it into records. And the way it does that is similar to the for each scope. If you've used that, you basically give it an array and it takes each individual element of that array. So if you want to set up your batch scope so in a sort of different way, you can give it arrays that are subsets of the payload, or you can give an array from a variable. You can set that all up, but whatever array you give it, it's going to split it down into the individual elements of the array, which are called records in the parlance here, in the way MuleSoft describes batch. So it's going to split it down into these individual records, and then it's going to create a single queue for all the records. All the records get loaded onto this queue. It's one queue for all the records. And then it spins up threads to start handling these records and moving them through the batch job. Those threads are the Mule engine's threads itself. You can adjust how many threads it uses, but the limit is basically twice the amount of threads that the Mule, twice the amount of the maximum amount of threads is twice the amount of cores that the Mule engine has access to. And the reason for that is just that if you're trying to use more than that, you're not really getting any advantage. The parallelization is sort of limited at that hardware level. The second phase of this batch job is in the actual processing, sort of the meat of it. And what happens there is a thread will come to this queue, pick up the top record, and then process it through a batch step. And each record is its own little self-contained unit. So each record keeps track of which steps it's been through. And so when a thread comes and picks it up, it processes it through the next step, whatever step that might be. And then when it's done processing through that step, it'll get returned to the same queue that all the records are on. And that sort of concept is pretty important in understanding some of the tricky parts about batch that we'll get into later, some of the sort of gotchas about how you're setting things up. The sort of key realization for me as far as understanding these sort of edge cases and how they worked is recognizing that each record is its own little self-contained unit. So the decisions about how the batch job works sort of have to take that into account, and we'll see more of that later. Each record passes through each of the batch steps, and failures happen at a record level. So if you have a record that fails, the other records won't fail, and that record will just not be processed through the rest of the steps. This is in contrast to the initial load and dispatch phase. There, if there's any failure, like if the batch job fails to split your payload into records and fails to create this queue or fails to spin up these threads, then the whole batch job fails as one. But once you've got the instance actually created and running, then it fails on a lower record level. The final phase of this batch job is this on-complete phase. And this can be a bit of a gotcha. The on-complete phase, you would think you could use it for sort of accumulating all your records, doing something with all the records that you've processed. But actually, you don't have access to any of the records in the on-complete phase. The on-complete is only for sort of metric aggregation over the successes and failures during the batch job, and for doing something based on those successes and failures. So again, you don't actually have access to your payload or to those records anymore. You have access to a batch job report object, which tells you the amount and number and kind of errors that happened and which records errored and what step they erred on as they process through the batch job. So that's something to be aware of. In that on-complete phase, you're sort of looking back over the whole job and addressing success and failures. You're not actually finishing up the job at that point. It should be already completed. It's on that completion, you move on and do some remediation or something like that. So our first trivia question: which of the following is true in a batch job with two batch steps? Every record starts step one at the same time. Different records can be in different steps at the same time. After a record finishes step one, it immediately starts step two, or all records will finish step one before any records finish step two. So Brian and Stephanie, if you want to let me know once people have finished submitting answers.
Give it a few more seconds. And looks like the majority of the responses are letter B. Is that correct?
B, that is correct. Excellent. Yeah, so every record doesn't start step one at the same time. They go into that queue and get picked up by the threads. So later records in the queue obviously aren't going to start step one at the same time as earlier ones. B is definitely correct. If you have a batch step that has pretty variable times that it takes records to process through it, you can have a record go through it very quickly, go back into the queue, and another record go in and be processing very slowly. The queue moves all the way through, and that first record goes on to step two before the second record has finished step one. For that same reason, same explanation, C is incorrect. It goes back into the queue before starting step two, and D is sort of a rephrasing of that same thing. So congrats to whoever got that one first.
So our winner is Vikas Gupta. Vikas, if you could give us your email address, we'll be sure to submit your information to MuleSoft Meetup team.
Well done, congrats. All right, batch aggregation. So this is the first sort of more advanced use of batch processing. If you'll remember, I said that you could put an aggregator at the end of each batch step. You don't have to have one, but what it allows you to do is to do something with a subset of your records. That can be up to the entire set of records, or it can be just, say, 100 out of 100,000 records. And the reason you might want to do this is, say, if I'm reading a million records out of a database and inserting them to Salesforce, I may want to modify each of them individually based on some properties or some other information I might have. But I'd rather insert them in chunks rather than as a million individual inserts. Respecting Salesforce's governor limits is pretty important. They sort of shut you off if you do not do that. So you want to be uploading a chunk of records instead of one at a time. And this batch aggregator is what allows you to do that. There's two sort of diametrically opposed settings for this. You can choose a fixed size aggregator or a streaming aggregator. And a fixed size is sort of the straightforward option. You choose a size called a block size that gets loaded that you want to aggregate at once. So you say, I want 100 records, and your aggregator, that batch step will run. Each record will process individually through that batch step. But once it reaches the aggregator, it goes into a separate queue that thread has individually. And that sort of separate queue fills up to 100 records and then gets processed through that aggregator at once. So that allows you to do that bulk insert or that upsert to Salesforce. And it's that's sort of the default way of doing things with this fixed size aggregator. This is also where some of the optimization of your batch job can come in. So looking back at this queue with the records, each thread is not actually taking one record off at a time in most cases. So in most cases, you're going to want the threads to be taking multiple records at once. And the reason for that is to sort of minimize the memory cost of running this batch job, where again, if you have 1 million records and 3 batch steps, that's 3 million I/O operations that MuleSoft has to do, which is quite a bit. But if you set your block size to be 100, then suddenly it's only 30,000 I/O operations that it has to do, since each of those threads will come and take a block of 100 records off the queue at once. So that's sort of one pressure pushing your block size upwards, is that you'd like to load as many of these records into memory as once as you can. But the flip side of that is that you don't want to load more than your memory can hold. If you're trying to load more records than can fit in your memory at once, your threads are going to have to be swapping those records in and out, and you're back to having more I/O operations. So raising or lowering the block size is one of the sort of key ways of optimizing your batch job to use memory efficiently. So you're taking advantage of the multi-threading of the parallelism that the batch job provides, but you're not incurring too steep a cost in, like, you're not losing all that advantage in having to do a million individual I/O operations with these threads. So that's the fixed size aggregator. The other one is a streaming aggregator. And this comes again into sort of the core of how MuleSoft works. Turns out that you may have seen this if you saw Joshua Ernie's DataWeave presentation, is that MuleSoft payloads are really sort of repeatable streams. And because of that, you can stream even very large data sets through a connector without running into an issue. So if I want to stream all million records through this aggregator, I can do that. Now, obviously, they're not all going to be in memory at once, but the advantage of the stream is that that's sort of obfuscated away. It's taken care of. You don't need to worry about that. And it just handles it all for you. The downside, though, of course, is that you have something of a performance hit using a stream over just accessing them in a fixed size chunk. There's still this memory cost, and there's sort of this fundamental performance hit to using this as a stream. But the benefit, of course, is that you aggregate every record in an entire instance, an entire batch job that you're running. So this is really optimal if you're writing to a file. For example, there's some other use cases, but this is probably the most common and most useful one, is I want to write these million records into a CSV file. Well, I can have a streaming aggregator at the end of my batch job. And that way we'll do all the processing in parallel, all the modification and edits that I need to do on these records. That all happens in parallel. And happens multiple times faster, and then it gets streamed into this file as fast as Mule can do it. One more thing to be aware of when choosing between these aggregators is that a fundamental part of the streaming aggregator is that you are accessing records in order, sequential access. So you can only access like the current record. And that's sort of a fundamental aspect of how streaming works. MuleSoft uses repeatable streams, so you could go through the whole stream and go back to the beginning to get those earlier values. But in general, that's not really what you're going to be doing. You're just going to be reading each record once and then moving on to the next record. With the fixed size aggregator, you have random access. So you accumulate 100 records. You can access any of those 100 records at the same time if you want to compare or average, do things like that, change values based on comparisons between two records. For that sort of use case, you're going to want to use a fixed size aggregator because you get that random access. So that's sort of the difference between the fixed size and streaming aggregator. The basic purpose, though, is the same of I want to aggregate some subset of my records within a batch step and do something with them as a whole rather than processing them individually in parallel.
Hey, Ben. So I think we have a question on chat, which I think you may have just covered. The question is, would like to know handling for large files using the batch module, especially with an SFTP inbound limited memory, essentially how to efficiently read and process such a file without hitting an out of memory error. I believe you discussed streaming. Would that would apply to this particular question? Right?
Yeah. So with those very large files, you're going to want to be streaming them as much as possible. And that'll help you avoid that out of memory error since you only have to hold part of the stream in memory at any one time. So you have to be careful about the connectors. and make sure you're using streaming throughout, but that should handle your issue there.
And I think you're going to talk more about how to handle like exceptions or
yeah, certainly.
Okay, we have two more questions. I'll just defer those until you get to that part of your presentation. Awesome.
Yeah, I was talking about error handling at the end. So if they're related to aggregators, I can certainly address them now. But
well, one question is, how do you reset a batch job so it doesn't try to reprocess records it held when abruptly stopped? For example, with 1,000 records, you're processing the 300th, system crashes. When it comes back up, is it going to continue processing the rest, or does it start new? And then the other question is, how do you exit the batch job mid-processing under certain conditions? I think that one you said failed record handling, but
yeah,
you can
yeah. So for exiting the batch job under certain conditions, we'll get into that later. That's definitely something you can do with error handling. I'm not actually sure of its behavior. You're saying like if Cloud Hub crashes, what happens to an in-progress batch job?
Or if you have an on-prem or hybrid installation, so you're not necessarily running Cloud Hub. I think that's the question here.
Yeah, I'm not sure actually what happens in that case. I'm not very familiar with MuleSoft's process in rebooting current jobs in progress. Aaron, if you have an idea on that, I'm certainly open to any help there, but just not something I've run into so far.
I don't know if Aaron has either. And the one other question, which isn't in chat, but it was asked to me, the use case is if you have duplicates and you're loading Salesforce, can a batch job check for batch scope check for duplicates, or is that going to be, or how's that handled?
You certainly can. One of the nice things about the batch job is that it integrates well with a couple very common connectors. So the Salesforce connector, the database connector, NetSuite connector, there are more, but those are probably the most used ones. All of these can be used in aggregators and can do sort of best effort attempts where you give it 100 records to the Salesforce connector to upsert. It can upsert as many as succeed, and if it runs into duplicates, those will fail, and it'll just continue to try the other ones. But it will also give you a record of which ones succeeded and which ones failed. So that should be able to handle that. That's one of the nice things about the batch job. It does that sort of abstraction away of the parallelism, and it also has some of these nice integrations with pretty common use cases.
Yeah, and Ben, I was thinking about the previous question.
Yeah.
I didn't get a chance to speak, I guess, before we moved on to the next question. So the question was about batch and on-prem.
I was saying if you have a batch job running and your MuleSoft install crashes, when you turn MuleSoft back on, what happens to the in-progress batch job? At least that was my understanding of it.
Yeah, that's the way I interpret it, because some of the chat about Cloud Hub, it'll basically restart where it left off, is my understanding.
Because of the VMs in the background. Yeah, that makes sense.
Mm-hmm.
Yeah, I think that's something I'm curious about too. I'm because you can have a cluster in a hybrid deployment, and if you're maintaining state and sharing memory across the cluster, hopefully you're in a highly available environment anyway, in a production environment. I believe you one of the other nodes in your cluster would pick up the batch job. I would have to confirm that though. I'm not sure.
Yeah, not sure either. But
and there's another question, and I don't know how you would do this. The question is, can we abort long-running batch jobs on demand? Like in Salesforce, they could abort a bulk API v2 job by sending an abort API request to job IV init. I don't think you have that control in MuleSoft, but I'm not sure.
Don't think you do either. You certainly, yeah, I don't think you do. You can access records about the job using the job instance ID. And in Cloud Hub, you can view the queue that it's using, but I don't think you can shut it down. Shut it down sort of ad hoc.
Yeah, I don't think you can shutting down the batch ad hoc. What I would recommend there though is using the timeout of the particular system that you're connecting to. So whether it's HTTP or Salesforce or something else, set a reasonable timeout that would sift through your records in a reasonable amount of time, so that you don't run into a really long running batch job.
Right. Yeah, this is definitely something we can get into more with the error handling again. Is that there's a lot of flexibility in your batch job of what you can sort of set it to withstand, or what you can set it to ignore, or what you can set it to stop based on. And so if you set those time limits on whatever external connection you might have in your batch job, whether it's a database or a Salesforce, if you set those time limits to whatever you're comfortable with, you can have it stop processing after that time without any issues.
Cool.
Yeah.
All right, that's all I have for now. Keep going.
Sweet. I think the last thing I had on this, one more thing to be aware of here is that transactions within a batch step end before the aggregator. So there's sort of two pieces to this. One is that you can have a transaction within a batch step. MuleSoft allows you to set up transactions pretty easily using the try scope. A transaction, for anyone who might not know, is basically a set of operations that you declare has to either succeed together, or if one fails, they all fail. You want to say all of these must succeed or all of these must fail, so that you don't get sort of partial updates and corrupted data going through if something later in the process or later in the transaction fails. You also have to make these pretty easy to set up, and with the try scope sort of integrating with various different connectors to do that. And you can do that within a batch step. So one step of a batch job can have several processors that are as a part of a transaction, and when a record goes through that step, it goes through that transaction, and the boundaries of that transaction are respected. So if one of the processors fails, everything that transaction would have done is rolled back, and then the failure is propagated. You can't extend that transaction into the aggregator. So you can't have processors within the step doing something within the transaction, and then if the final bulk insert fails, you can't roll back what happened during the transaction sort of automatically. The reason for that goes back to the idea that these records are sort of self-contained units. And when they're coming together into this batch aggregator, that's sort of crossing a wall there, and you don't really have access to roll back the things that happened within the batch step. That's something to be aware of. Also, as sort of larger view of a larger perspective of this, you can't have transactions that cross multiple batch steps. The records are going back onto the queue in between the steps. There's just a lot of space and a lot of problems with declaring that these multiple parallel steps all have to succeed or all have to fail together. So sort of defining that to be not something you're allowed to do lets MuleSoft abstract away a lot of those race conditions and that parallelism trickiness that you would run into. Parallelism in transactions is very hard to do. So allowing you to have transactions within a single batch step is sort of the maximum without allowing a lot of problematic edge cases. We'll now go into our second trivia question. Which of these is reason to use a streaming aggregator instead of a fixed size aggregator? You want to sum a value across all your records, you're loading data into Salesforce, you want to access multiple records at once in your aggregation, or you want to optimize performance of the batch job.
We should have brought, not only should we have brought Tina Turner, we should have brought the Jeopardy theme song. So I'll take notes for that.
Yeah.
Next time we have our trivia questions here.
I'm sure you can just sing it for us, right, Brian?
I'm sure I could too, but we're recording this, so I've been recorded a lot the last year or so, so I'm just a little afraid to keep. I'd rather let other people participate in recordings.
There's a bit too much publicly available information.
There's too much publicly available information, which I may confirm or deny actually exists.
Yeah.
Ben, the answers are honestly all over the place. What is the correct answer?
The correct answer here is A. You want to sum a value across all your records. So streaming aggregator is going to allow you to do this. Again, streaming aggregator, you're streaming your entire set of records through this aggregator. And you could have a counter variable that is summing as each record passes through. So that's pretty clearly a thing you can do with the streaming aggregator. It technically is something you can do with a fixed size aggregator if you set your block size to be as big as your entire amount of records. The reason not to do that is then you're not processing in parallel at all. If you set your batch size to be equal to 1,000,000, one thread picks up all 1,000,000 records, and then you can sum them all using your fixed size aggregator if you don't run into a bunch of out-of-memory errors. But you're entirely losing the benefit of batch in that case. So if you want to sum a value across all your records, you'd use a streaming aggregator. Fixed size aggregator, you could sum a value across all, say, 100 records that it picked up, but you wouldn't be able to combine that with all the other records that are passing through the batch job. Going through the other ones, loading data into Salesforce. This is one where you want to use a fixed size aggregator. Like I mentioned, Salesforce has governor limits, limits on the number of operations you can do at any one time or within a time period. And in general, SaaS, software as a service, platforms are going to restrict your ability to just sort of stream unlimited data into them. So using a streaming aggregator with those sort of SaaS platforms is often going to be running into their own restrictions on how you use their APIs. C, accessing multiple records at once. With a streaming aggregator, you're only accessing the current record. So you can't access multiple records, whereas with a fixed size aggregator, you have that random access. You can't access any of the records that it's picked up. And then finally, optimizing performance. Again, the streaming aggregator has a performance hit. It's going to be slower, sort of no matter your settings on your fixed size aggregator. And conversely, the fixed size aggregator allows you to tune it so that you're minimizing the I/O operations, maximizing your use of the available memory, and taking advantage of all the threads you have access to. So that would be, optimizing performance would be a reason to use a fixed size aggregator. And generally, unless you have a case where you need the streaming aggregator, you're going to want to use the fixed size aggregator. That should sort of be your default go-to.
Awesome. So our winner is Kunal Kapoor. Kunal, could you send us your email and we will make sure we submit your information onto MuleSoft. And one last question about streaming. Does a streaming aggregator work like streaming in Java?
Yeah, so under the hood, these are Java repeatable streams. MuleSoft handles almost everything you would have to think about with using streaming. It sort of just works. Whenever you're using MuleSoft, you're using streaming without knowing it necessarily. Your payloads that streamed in, they're repeatable streams, so it can be consumed by multiple connectors. But this all sort of happens in the background. MuleSoft is in Java at the core. So sort of fundamentally, yes, it works in the same way as a Java stream, but that probably won't give you a lot of intuition for how to use it in MuleSoft.
All right, thanks, Ben.
Yeah.
March on.
Onwards. Variable propagation. This is a bit of a tricky one. This one tends to show up on the MCD exam, the Mule Certified Developer. So if you're planning on taking that, pay close attention here, because there's always at least 1 or 2 questions on it. And again, the thinking of records as these sort of self-contained units was the way for me to sort of internalize all of this. The way variables work is that each record has its own set of variables that are propagated with it. So it has the data on like what step it's in, what errors it has run into so far. It's got the payload itself, that record, and then it also has the set of variables associated with it. So if you create variables before starting the batch job, each record is going to get its own instance of those variables. So in your batch steps, if you edit those variables, you're editing that record's version of those variables. So if it's edited as one record goes through, the next record is going to have just an original clean version of that variable. It's not going to see the edits that happened in that first record. Same thing continues true into the aggregators. In the aggregators, you actually have access to every variable attached to every record. So if you have a fixed size aggregator that takes in a block of 100 records, you have access to 100 versions of that variable. So in that case, you can compare those different values, but they're not all combined into one variable. And finally, in that sort of on-complete phase and even after the batch job, those variable modifications sort of disappear with the records. They're attached to the records. They don't propagate out into the variables. So remember, batch job's asynchronous. You have a couple variables, A and B, coming in. Each record gets a copy of those. It can modify those and use those modifications as it will. But after the batch job, you're still just going to see the original values of those variables. And similarly, if you create a variable inside a batch step, it's not going to be visible outside of that batch job at all. And then finally, error handling. So in batch, error handling can obviously get a bit tricky if you've got millions of records coming in. You want to be careful about how you're messing with the logging and what you're doing with that. Like I said before, records fail at, or there's failures at a record level in general. So if a record runs into an exception, it records that exception. That data sort of stays with the record and continues on with it. It also gets logged in some cases. The first time an error happens in a particular batch step, it gets logged. So if I have a batch step where I'm doing a transformation and I try to do something with the null value, that null exception, that'll get logged with sort of saying like, this step had an exception. But if the next record comes through and runs into the exact same problem, that's not going to get logged. You don't want to have a million of the same log coming through. So that is going to be recorded, but you're not going to see multiple logs of the same error. Different errors will get different logs. The same error on different steps will get different logs, but those same errors on same steps just get logged once. And then at the end of the batch job in the on-complete phase, part of the information you get is a list of what errors happened, where, how many, and on what steps. Yeah. I think I said where twice there. Yeah, what errors happened, what steps they happened on, and how many times they happened. So you can use that information in your remediation or in a report about the batch job. And that's sort of how the error processing works. Again, this on-complete phase is for this more reporting perspective. You're not doing something with records. You're not aggregating them all together. If you want to aggregate all the records at the end of your process, you use a streaming aggregator in your last batch step. On-complete is after the batch job is finished. You're getting sort of reporting information on it. And the final thing is getting back to some of those questions we talked about earlier, is that the batch job is very flexible in what you can do to sort of modify the processing as it continues through. So there's an accept policy and accept expression on each batch step. And those allow you to filter the records that go into that batch step. So the accept policy has 3 options: no failures, only failures, or all. The default is no failures. So if a record fails a previous step, it's not going to go into any of the subsequent steps unless you set up a step to accept failures. And you say, well, if it failed in this step, it goes into this and we do something with it. Maybe we log it, maybe we try it again, maybe we send someone an email about it. And so that's how you can handle those failures on sort of a more specific level. And if you want failures to just continue through as normal, you're like, yeah, they're our best and we'll do something else with them. You just want to continue processing, you can use that all accept policy where failures and non-failures just continue through. If you want to get more specific, if you want to set up some more filters, you can use the accept expression, which does specific validations. So you might have a call in your batch step where you're getting some information back, and you want to make sure that all the dates are less than today or greater than today, or you want to make sure that a certain integer is greater than 20, or any number of validations. Anything you can think of, you can set up an accept expression to do that in DataWeave. And so this allows you to sort of fine-tune your processing to have specific steps that only accept certain records. And the nice thing here is that you also get access to the record logs of what exception it has encountered. So for each record, you can access what's the last exception encountered, what's the array of exceptions it's encountered, and you can really fine-tune your processing for those failures to handle them in whatever way they need to be. That's sort of our deep dive into the batch scope. If anyone has any questions before we go into the demo, now would be a good time.
And just following up on the question of deploying on-prem, whether it's on-prem or hybrid. Mm-hmm. If you do have a cluster, like I was saying, that was correct. If you have a cluster and a node goes down, you will still continue the batch processing. I'll put a link here in the chat that has a really good description and a couple good visuals on that. So if you have, let's say, 2 nodes in a cluster, node 2 goes down, node 1 will continue to process those messages that node 2 was processing. So if you're on-prem or hybrid, obviously I highly recommend to cluster for the benefits that you get there for high availability. If you're not highly available, you would not continue processing. Would be the answer.
Makes sense. Thanks for checking that out.
And Ben, there's one more question on chat. When would you use a parallel for each over the batch step?
Yeah, so parallel for each, definitely useful, but doesn't allow you the same sort of level of control over your parallelism, over your memory usage that the batch step allows you to do. So if you just have an array and you've got pretty straightforward operations that need to happen on it, and you need each of those operations sort of go through to the end, like you don't have multiple steps within it, like a parallel for each isn't going to be having isn't really the equivalent of multiple batch steps unless you're using multiple parallel for eaches. So it can accomplish a lot of the same things. Batch job gives you some more control over it, gives you the aggregator, which you don't have in the parallel for each, and sort of optimizes this to handle it as best as MuleSoft can.
Right, let's go on to the demo. I saw one more question coming. Let's go ahead and pick up your demo and I'll come back to this question.
Okay. All right, so we've got a pretty straightforward batch job here where we've come in, we've loaded contacts from database in Sales or in GCP, just an SQL database that has some basic contacts, and then we're going to be doing a little modification on them, inserting them into Salesforce with this fixed size aggregator, and then doing a bit more transformation and writing them to a CSV file with this streaming aggregator. You can see here in the log, as the batch job is created, it creates what's called a instance for the batch job. So this batch job instance is like one run of the batch job. All the records, that queue, that's all attached to this batch job instance. We've got that loading phase that I talked about, where it's creating this queue, splitting the payload into records, and then spinning off threads to do that. And then it should start execution, though I was running into a bit of an issue earlier where this batch job was just not starting. Execution is started, but it doesn't seem to be actually reaching the first batch step. We'll leave that running for now. We'll see if that makes any progress. Sorry about that. Here's a pretty simple batch job. We'll actually use this for our next trivia question. So what values will the logger on the onComplete phase print? So we have a counter that's created at the start of this batch job. That's an external variable, so it's counter to 1. We've got a payload with 3 values. So the batch job is going to split that into 3 records. Each one is going to increment the counter and then set the step variable equal to the counter. And that's going to happen for each step. And then in the onComplete phase, we're going to log the counter and step var. So which of these will that logger show?
And the Jeopardy music has just ran out. If you didn't hear it, that's because I didn't hum it that loud. And so the question is, you went ahead.
Yeah.
So what would be, what's the answer? Most people said A.
It is correct. Like I said, the modifying variables within the batch job aren't going to impact aren't going to be visible. Those modifications and creations aren't going to be visible outside the batch job. And the onComplete phase, despite appearing within the batch job, is sort of outside of the scope of these records. So we can see, should be able to see this. Processing through. Oh, I think we actually. Yeah. May have to restart this. Does not appear to be triggering my job. Well, this goes. Are there any other questions about batch that I can answer for you?
So the correct answer was A on the last one, right?
Yes, that's correct.
Okay. So our winner is Hari Manan. Hari, if you can go ahead and send us your email, you can go ahead. We'll be able to submit that over to MuleSoft while Ben gets Anypoint Studio working again. So there were 2 other questions. If using, okay, so this is back to the SFTP question, but slightly different question. If you're using batch, if you're listening to SFTP, is it better? I'm not sure if I understand this question. if using batch as an input component, listening to SFTP, better to add other components and steps or save off data and have external flows pick up the processing?
Can you repeat that? Sorry.
I'm reading, I don't even understand this. It seems like if you're using batch listening, is it better to add other components, I think, in your batch steps, or just save the data and have external flows pick up the processing, I guess, of this other data?
I think, if I'm translating this in my head, they're kind of talking about synchronous batch processing versus async.
Okay.
Like publishing events out instead of processing it all the way through, you know, in the batch records. That's what I'm. Ben, do you have any thoughts on that?
I'm still not quite sure. So, like you're saying, running your batch process, is it you be publishing events out like in those batch steps?
To a queue, for example, is kind of what I'm envisioning, or at least seeing in this question.
I mean, if you're publishing them outside of the batch, if you're sending them off to a queue, you're sort of like, you want to handle all your parallel processing first. Once you're external of the batch job, you're not getting the advantage of that parallelization. Sorry, I'm having some trouble conceptualizing this.
I think that's
question.
I think that's fair. I think there's use case. I mean, I'll chime in. I think there's use cases where you might. I think Ben is pretty spot on there. But also, let's say you have to deal with a really, really large batch, and you can't load that all into memory. So you need to select from a database 1 million records, let's say. Mm-hmm. And Ben, one of the questions, or at least subject I was going to bring up, is pagination and how it relates to batch as well. You know, what you might consider is a queue somewhere in the process to be able to split up 1 million records into smaller chunks, because there's going to be limits on the number of vCores that you know, or cores if you're deploying on-prem, that you can throw at these types of applications.
Yeah.
Just a couple of thoughts there. Ben, I don't know if you want to comment more on how pagination relates to batch?
I mean, yeah, it sort of goes back to that same fundamental, these are streams. So you generally don't have to worry about how it's handling the pagination of the streams. It just sort of handles it by itself. So generally just using that streaming aggregator is enough to handle sort of any amount of data. But if you do want to have like split that into multiple sections, like you said, if you've got a batch job that's going to be running a very long time, sort of longer than you're okay with sort of leaving it unattended, and you want to process it in smaller chunks, that could certainly be a case for that.
Is your demo back up, or is it still just hanging there?
This one's back up. Here, let me.
Right now we're seeing the slides, just to let you know.
Yeah. Perfect. I was doing some fast debugging behind the scenes. So here's this one. We set counter before the batch step. So again, inside this batch step, we can see the value of counter, and that value will get modified to 11. So if we had a logger in here, we would see 11. But step var gets created and then immediately goes away when we go into the next batch step. It's attached to that previous record. That record finished the step. We're on a new record. We don't have any information about what that previous record did. You can see step var is back to null, counter's back to 1. And the same thing happens when we finish the whole batch job. Counter and step var are 1 and null because we don't have visibility on any of those changes that happened inside any of the steps. This, I think, is still. Let's stop now. Yeah, I think this demo is not going to make it today. I'm very sorry about that.
So what were you trying to do in the demo?
Yeah, so I can show you the setup of these. Selecting contacts from the database, and then in the first batch step, just doing some straightforward modification of them, combining the names into one. We have a create here, where we're uploading to Salesforce this array of contacts. This array will be size 100, since we've chosen that here. Then all those records, they'll go back into the queue. They'll be processed into step 2, where we'll add a static value, transform them to CSV. So this is just using DataWeave's CSV writer to do that for you. And it'll stream it straight into this writer, this file writer. And since we're using the streaming aggregator, this will stream through all of the records in the entire batch job. Yeah. I think that is it for my presentation. Happy to answer any questions. I'll stick around, but I think I'll fork it back over to Brian.